as I was just saying, at the end, I'm going to take any questions you might have on the test. The test was one of those where it was a hit or a miss. You know, there weren't a lot of middle grades. You either knew what you were doing or you didn't. And I think the week of spring break killed a lot of people as far as taking them out of their mojo and everything. And I could see a lot of common errors. But I did go over the test with a couple of students, actually. They had questions, and I have another office hour this afternoon, and they're like, oh yeah, could have gotten that one, should have gotten that one. And yeah, and a bunch of regrets. So I think people will learn the material. It was just putting it together to see if they could get the problems right. And I think, Johnny, you were one of them. You and I went over the test already.
Yeah, we went over it. Yeah. I
Yeah.
went over it again and I realized all the things I got.
Yeah, you could have nailed it. I mean, you could have gotten a really, really, really good grade. But so, like I said, I'll take any questions at the end of class today that you may have. Hopefully you went over the test after it was graded. And yeah, I'll take some questions because you're coming up on the final exam. You know, that's not that far away. Today is class number 20, which means we have 8 classes left after today. So, and some of those are built-in reviews. But let's get ready and see what we have going today. Now, up to this point, there it is. We love that guy. We love that triangle. This was called a right triangle, and we got right into triangle. We got right into SOHCAHTOA, and we went crazy, and so much was built on that. It was built on the 30, 60, 90. It was built on the 45, 45, 90. And we spent all kind of time working with this right triangle, and we covered a lot of stuff. But now, doom and gloom. No, it's not doom and gloom. What if I get a triangle like this? What if I get something, and this is called an oblique triangle? And what do I see about an oblique triangle? When it comes to an oblique triangle, I don't have 90 degrees. I don't have 90 degrees. 30, 60, 90. Nope. 45, 45. Nope. SOHCAHTOA. Nope. None of those come into play. So what I need to do now is I need to learn how to work with this guy that's called an oblique triangle. I don't have 90 degrees. You know, here's an example of an oblique. Here's an example of an oblique triangle. You know, that looks close to 90, but if it's not exactly 90, I can't be using 30, 60, 90 for SOHCAHTOA. I can't use any of those things. We commonly name our triangles A, B, and C. We have lengths across from capital A, my angle A. I have little a, and that's the length of that side. Across from angle capital B is going to be little b. And then, of course, across from C is little c, which is confusing because they look so much alike other than the font size. But they are so much alike. Well, somebody sat down and said, all right, I want to start to talk about these things called oblique triangles. And nothing looked good, nothing looked good. And all of a sudden they said, well, what if I take this top point and I draw a line, word you learned somewhere along the way, perpendicular to that base. If I draw a line perpendicular to that base. Well, once I have a right triangle, a whole bunch of things can now come into play because I have this height h. And now I can start saying, well, some of those things I crossed off, like the big one, SOHCAHTOA, can come back into play. For example, I could say the sine of angle C is opposite, which is h, over Here we go. Opposite over hypotenuse. Now I'm able to talk about some of these things. The problem is I just have this H, but maybe it's not a problem because I can get back into doing things that I was doing before. Right? So I just threw a smattering of stuff out, and let's start to look at some of the more official notes. An oblique triangle. Triangles other than right triangles. We just discussed that. We're going to get into something called solving the triangle, which means if I give you certain pieces, angle measures, sides, you should be able to calculate what the rest of them are. So solving the triangle means I should end up with 6 values: big A, big C, big B, the 3 angles, and the 3 sides. One of the things I know is still, in my inventory on all triangles, the 3 angles add together to be 180. Side note, triangle, 3 angles, right? What do they add up to be? Well, we just said 180. If I did a square, I now have 4 angles in there. Yeah, so they add up to 360. If I had a pentagon, that has 5 angles. What do those 5 angles add up to be? Just, this is curiosity's sake. This is extra for experts. Does anybody know what the 5 angle? Patrick?
I don't know, 520.
540.
540. Yeah, it increases by 180 each time. So if I went to 6 angles, and I kept going, that would add another 180 to it, 720, and I would just keep going. Okay, just a little something. A lot of you had geometry class. This was something in geometry class. But that's just, yeah, if I do a pentagon, each of the angles would be 108 degrees. For real? For schnizzle. Yeah. Okay, but anyhow, we're keeping it simple. We're keeping it real. The 3 angles, capital A, capital B, capital C, of a triangle add together to give me 180 degrees. All right. A moment ago, when we were doing the introduction, I said, oh, we can take this oblique triangle. And one of the things I can do is draw that height. Sine of A equals H over C, opposite over hypotenuse. I can do the sine of C. That equals H over A. In fact, I could draw another hypotenuse and get the sine of B. And what do you think the sine of B would be? Well, it's the same kind of concept. Depends how I drew the triangle, how I drew the height, and so forth. But what I end up with is a relationship with this H, okay? I can deal with angle A, I can deal with angle C. And if I do a little work with this bad boy, I can say, wait a minute, I know what H equals. Do you? Yes, I do. Little c times sine of A equals H. And if I look over here, I say H equals little a sine of angle C. Huh. This formula is going to come out and it's going to be really nice and useful for us. It's going to be nice and useful. Well, this equals H and this equals H by the transitive property. C sine of A equals A sine of C. I like it. Check this out, Funk Soul Brothers. I can manipulate this. I can divide by C. I can divide by A, and I get sine of A over A equals sine of C over C. How about that? Or I could flip them little a over the sine of a equals little c over the sine of c. And what I'm doing is building something to work at it. I'm putting this now in my inventory. A reminder, a plus b plus c equals 180, puts it in my inventory of things to use. Here I now have little a over sine of a equals little c over sine of c. In fact, I could even take that one step farther where I could say, okay, sine of a over little a equals the sine of c over little c. And if I wanted, I could in fact say this is true as well. So the law of sines is what you see here. Sine of a over little a, sine of c over little c, or sine of b over little b. They are all good. Now, what whoop-de-doo, why do we care? Well, up here a little while ago, I said, we're going to be solving the triangle. Means if I'm given certain pieces, I can tell you what the rest of the sides or angles are. And this is now going to help. This is going to help. In fact, I'll be able to use this if and only if I'm given 3 pieces of this puzzle. And the 3 pieces are an angle, its side, maybe another angle. Then I could find C. Or if I'm given A, big C, and little c, I could find little a. Or if I'm given little a, little c, and big C, you know, I can find and do the calculations to find some missing parts. So all of a sudden, you now start to get into, okay, so I want to solve this triangle. I'm giving you big A, big B, and little a. And some of you remember from geometry class. Let's see, I'm going to draw this triangle. And this isn't exact, but I know this is A, this is B, and this is C. This is little a, little c, and little b. And I want to solve the triangle. Let's see, I'm given A, which is 32 degrees. I'm given B, which is 81.8 degrees. I'm given little a, which is 42.9. And now some of you are going to get ready and go, okay, so let's see, here's what I'm given. An angle, I'm going around. I'm given an angle, and a side, AAS. And you remember, you get into these 3 pieces. You know, if I'm given the angle, and the side, or I could say side, I can say different things, but this is an angle, and a side. When I have that, I'm able to complete this triangle. Cool. Cool.
Would lower B and lower C also be 42.9?
Nope. My triangle is just shaped that way. I just laid it out. This is not an equilateral. Yeah. Because you can see this is 32 degrees and maybe, but this is 81. Yeah, it's not drawn to proportion. Good question. Good comment. All right. I have A, I have B, and little a. That means I need to find big C, little b, and little c. Well, I don't need to find them. They're not lost. I do know big C is going to be 180 degrees minus 32 degrees minus 81.8 degrees. What is big C?
66.2.
Excellent, 66.2 degrees. Found one thing, 6-point question on the test, 2, 4, 6. Little b, well, let's see. Do I have enough information up here to find little b? Yeah, by the law of sines, I need A, yeah, the sine of A, sine of 32 degrees over little a, 42.9, equals the sine of B, sine of 81.8 degrees over little b. I'm gonna run out of room here, but I could have flipped this the other way. So if I send the b up, I divide by that, and I'm on. So now I have b equals 42.9 times the sine of 81.8 degrees over the sine of 32 degrees. Calculator. On. I want second mode. Make sure mode, excuse me. I am in degrees. I wanted to make sure I was in degrees first. 42.9 times the sine of 81.8 degrees. I got an answer. Now I'm going to divide that by the sine of 32 degrees. I got, for an answer for B, 80.128. That's a length, okay? The little ones are lengths, the big ones are not. So I calculated B. I used the law of sines. First thing I did was I was able to get that other angle measure. Now I use the law of sines. Sine of A over little a equals the sine of B over little c. Well, I need to go one more step. I need to find little c. I can write it like this, as I mentioned a while ago. Little c over the sine of c equals little a over the sine of A. That's legal. I really did not leave myself much room. Little c equals A, which is 42.9, times the sine of 32 degrees, divided by the sine of, oh, that should be C, not A, 66.2, over the sine of A, sine of 32. Oh, calculator. Let's see. I want 42.9 times sine of 66.2. Divide that by sine of 32. Anybody else get that number? Anybody else get 74? Yes, good.
Yep.
All right, awesome. Nice. Let's see what we got. Solve the triangle. I'm pausing. Okay, so I'm taking a look at, I laid out my triangle. I filled in my values. I just need to see the picture in my head. You know, I say it throughout the semester, draw the picture. This time I'm given an angle, side, and an angle. Okay, there's, you know, we're dealing with this whole letter abbreviation system, and you remembered it from geometry class, a lot of you, but B is 36. That would have 36 for B,
Correct.
and that's degrees. And that was 180 minus, you know, here's one of my formulas, 180 minus A minus C is where I got that B from. The three angles add together to be 180. Anybody get an answer for little a?
305.5.
330.5? Did I say that?
305.5.
305.5. Good. Did anybody get it? And again, I'm starting to do some estimation skills. Like A is 31 and B is 36. They're kind of close to the same. So little a and little b should be close to the same. Let me say that again. Angle A and angle B are close to the same measures, roughly. And then looking at A and B, the sides, they're close to the same, roughly. Angle B is a little bigger than angle A. Side B is a little bit bigger than side. Now, it's not a direct proportion. I'm just using some estimation skills. And now C, it should be quite a bit bigger than A. All right, what do we get for little c?
$544.8.
Anybody else get that? Oh, get that degree out of there, you dummy. Anybody else get 554.8? Yep.
40.
I'm sorry, say again, Patrick.
You had it right, but you just said 54, but yeah.
I'm sorry, thank you. 544.8. Cool. And again, where's this coming from? I needed to find little a, and so I'm going to do little a over the sine of the a equals, and at this point, once I found b, I'm going to take little b over the sine of b, because this was my only unknown. I knew a, I knew little b, and I had just calculated angle b, so I was able to do the work to find a. And then something similar to that to find little c. Again, I wanted to find c, so I'm putting it up there. I could have done c over the sine of c equals, heck, I could have used this b over the sine of b again if I wanted. That's that's how my work. That's what I laid out.
So
Question?
hypothetically speaking, if
Yeah.
we needed to find little c, would we just put c over sine c to find the answer?
No, I needed to do the whole law of sines. That proportion is going to be equal to this proportion, little b over sine of b. Now, I could have, instead of this, used little a over sine of a to help me calculate c. That's side c. Yeah.
So like, what's the formula to finding like b over sine of b and so on?
For here,
Yeah,
this is the formula. So in order to do this, I needed the, so this was back, I was at this point. I needed to find little a. So I wrote the law of sines, little a over sine of a equals little b over sine of b. I wanted to calculate little a. So it's little a, which was my unknown, over the sine of 31.1 degrees. And I knew my equation was now going to be little b, which I already knew, 347.6 over the sine of big B, 36 degrees. So now by the law of sines, I knew 3 out of 4, I can calculate that fourth value. But I used this. A side and its sine in a proportion to another side and its sine. Does that help?
yes, thank you.
Cool, good. Oh, I actually like this problem. I hope you do too. It's my terrific handwriting. I should start to type these up so they look all pretty and official instead of handwriting. This is more of a personal touch. Yeah, whatever. All right, I'm going to pause the video. Let's see what we got. 2 ranger stations are on an east-west line, 110 miles apart. Got something that looks like that. A forest fire is located on a bearing of north 42 east from the western station. So this is the western station. And if I take a look at this, I'm seeing north 42 east. So if I come down this way, that's 42 degrees, and I'm seeing a fire up here. Well, this is 42 degrees. That means the rest of this has to be 48 degrees. All right. From the western station at A, so that we're calling A, and the bearing of north 15, oh, wait a minute, what did I mess up here? A bearing of north 15 east from station B. Well, here's station B, north 15 east is something like this. So I'm going to say, wait, this triangle extends up something along those lines. Because if I drew this, this is 15 degrees. So north 42 east, north 15 degrees east. So now I have a triangle and I got something, and again, I'm doing not a justice job here, but we said 42, which means this guy had to be 48. And we said 15, which means this angle has to be
105.
105. Excellent. This is 110. Cool. So if I know that they're 110 apart, this is 48, this is 105. I don't know if I need it or not, but I could quickly find that angle. That's kind of what we've been doing. How far is the fire from the westernmost station? I want to find this guy right here. We can call him whatever we want. We can call him little a. That means I'm going to call this big A. Well, I shouldn't do that. We already said this is A. We'll make this B, which means this is little b. Means this is big C, this is little c. I want to find little b. What are you doing, you clown? That's A, and this is little c. So I just read all that. I started a drawing. I made a drawing I can work with a little bit better. I want to calculate B right here. Okay, so if I'm going to find B, I want B over the sine of B. Good, that's my law. Equals, I don't have little a. I don't know that I can come up with little a. But what can I come up with? I can come up with angle C. And if I do, I can use little c over the sine of C. So yeah, I do in fact have to calculate that angle measure. Angle C is 27 degrees. And now I have enough to be able to calculate little b, which is what I'm looking for. Little b is the sine of b, sine of 105 degrees, equals little c, which is 110 over the sine of C. How far away is the fire? We need to send a helicopter. We need to take 110 times the sine of 105. Then I need to divide that by the sine of 27. It is, in fact, according to my calculations, 234.0397 or 0.04 miles. I'm guessing that's what we're working with, 110. That's kind of cool in a way. If you think, well, I know these two stations, and they're able to take that angle measure, and knowing that they're 110 miles away, that we can find out how far that fire is from here. We could find little a, how far is the fire from that station, and so forth. But the question says, how far is it from the westernmost station, which we called A? The eastern one was called B. And in our little world, we don't deal in hundreds of miles like that, but you head out west, you got miles and miles of unsettled land. Really? Yep. Oh, hey, watch out. Tomas, you are here. Good to see. Sergio, Sergio made it. That's good to see. Somebody else is here. Chuk, are you here?
Sir,
Chook is here. That's good. Chow, are you here?
Yes,
Okay, good. So yeah, we're missing 3 and it's the same 3. I can turn that off. All right, good. So the law of sines, again, I'm dealing with oblique triangles. The law of sines is great. And I'm going to tack something on to this lesson because it's going to also use the law of sines. And this is, what if I want to find the area of an oblique triangle? Okay, this isn't a regular triangle, but this is going to be the area of an oblique triangle. Well, I'm going to start with what's the area of a regular triangle. And a regular triangle we know is 1/2 the base times the height. But there's that oblique triangle that we've been working with. I have a base, but I didn't really have a height because it wasn't a 90-degree triangle. So I can draw the height in. We know how to draw the height in. And when I draw the height in, I go, okay, that brings into play sine of A equals H over C. And what is that? Well, yeah, this is going to be my height. C times the sine of A. So for this particular triangle, check it out. 1/2 the base, which is B, times the height, which is C sine of A. And if I would rearrange my triangle and turn it and put it a different direction, I might end up with 1/2 AB sine of good angle C. Or another option, you know, it depends on what I'm given. AC, DC, no, that's the AC sine of B. So one way to find the area of an oblique triangle is 1/2 the base times the height. But I know the height was my sine of A equaled H over C. Yeah. So H is the same as C sine A. If the world was only right triangles. So there it is. Cool. 2 examples. Try this one, try this one. I'm going to pause it so the folks at home don't have to sit and wait, and see what you can do with these 2. Let's start working on the first one. I want the area equals, this is coming from the law of sines. Oh, this is nice. AC sine of B. That's good because I have A, 34, times little c, which is 42, times the sine of 55 degrees, 10. Oh, we haven't done that minutes in a while. Equals. Let's see, I have 34 times 42. 4 times 42 times the sine of 55. Does anybody remember where I went to get degrees? Because I need to get degrees on here.
Go to mode.
We go to mode. No, this is to
No.
do the degree
Oh,
symbol.
on the,
it's second apps.
Second, apps. And oh, there it is again. Good. There's my degree, which is fantastic because I now need 10 second. And again, it was apps. It says angle in there. So maybe that's what I need to remember. And when I come in here, I can do my minutes. Yeah. The other thing was I could have changed 10 minutes into a decimal. That's that 1 over 60 kind of thing, 1 degree over 60 minutes and so forth. But I get an area of 1172,127. 1172.127 square. And it looks like I'm working with feet. Tomas.
Professor, are we not multiplying that by half?
Yeah, I screwed up. Thank you. Times 1/2. I was waiting to see if anybody would catch that. Full crap, aren't I? Equals the real answer. 586.60.63. 586.063 square feet. Oh, vey. Divided by 2. There, that doesn't look like I messed up so much. Thank you. Thank you very much. Let's see, I want to find the area. Area equals 1/2. Oh boy. I needed 2 sides and the other angle. I only have 1 side. I need to calculate another side. We want to keep this all together. What's the other side we want to calculate? A or C? Which of the formulas do we want to use? A. So I'm going to say AC sine of B. All right, so area equals 1/2. I don't have little a, so I need to calculate. I don't have little c. I need to find a couple of things before. What if I do this? I do have B. What if I make this A, B sine of C? Yeah. Because I at least have the B. All right, so the first thing I need to do is calculate little a. Then I have B in the sine of C, but I can't do little a because I'm going to do little a over the sine of A equals, I have that. Little b over the sine, I don't have big B yet. So I need to go find angle B. Once I find angle B, I can plug it in down here and get little a, and then I can keep going with my formula. For real? Yeah. A equals the sine of 24 degrees, 40 minutes equals B 27.3 over the sine of 180 minus 24 degrees, 40 minutes minus 52 degrees, 40 minutes. Boy, oh boy. 180 minus 24, that's going to be 155 degrees, 20 minutes. If I add those together, I get 1, 9, 10. I think that's right. That 120 was 102. Maybe I should have made these degrees. I don't know. Or decimal degrees. 20 and minus 40. And that's going to be. All right. Watchdogs. Let me know if I did that right or not. Well, I could quickly check by adding them together. 102 and 52 is 154. And 24 is 178. And 40 and 40 and 40 is 120. That's my other 2. Whew, yeah, I got it. Now, I did it this way. Y'all probably have other ways to do it, and that's fine. Yeah, that's that whole new math learning. We could possibly have 5 different students doing this 5 different ways. I'm not telling you the way I did it was right or wrong. That's just one of the ways. Sine of 102.40 Now I can calculate little a. Gonna send that bad boy up there. 1. And now I have 27.3 times the sine of 24. Oh, there it is, second apps degrees. 40 second apps minutes. So 27.3 times the sine of 40 degrees, 40 minutes. Got that answer. Now I'm going to divide it by the sine of 102. I have to go back to second apps. 102, 40. Go back to second apps, get my minutes. Whew. Little a is 11.678. So this becomes 11.678 times little b, 27.3 times a, b, c, sine of c, which is 52 degrees, 40 minutes. That's a lot of work. Well, we put a lot of pieces together there. 1/2 is the same as 0.5 times 11.678 times 27.3 times sine of. One nice thing about a graphing calculator, I can go back and check all my work several times. 52 degrees, 40 minutes. Area is 126.75. 746 square. Looks like probably some label like feet. On the test, if this was a test problem, would you be able to follow this work and box it in and everything's good? You know, I had a number for this, I'd number it. Some of you give me test work that, yeah, boy, you are all over the place. Problems aren't numbered. Your answer isn't boxed in. So for the next test, make sure you're making it a little bit more easier to read by the person who's grading it and not putting them in a bad mood. The other thing is, when the test is over, you have this many minutes to upload your work. You're not to be still working on it and submitting it 8 hours later. No, you have 15 minutes to upload it. And again, there's a couple of you that still don't like to upload your work on D2L, and it's hard for me to give you any partial credit when you don't. So, section 7.1 is now in the books. Any questions on what we've done up to this point today?